Okay, so today's lesson is going to start the new Unit 6, and we're going to talk about what happens when your variable is in the exponent this time, and, is there a parent graph for this type of function, and what are the characteristics of the graph. So, for example, if you had f of x equals 3 raised to the x power. Now, you should have talked about some of these in Common Core 1 or Algebra 1. So, in the lesson today, you're going to learn how to graph exponential functions and their inverses, identify exponential growth versus exponential decay, and graph transformations of the parent graph y equals a times b raised to the quantity x minus h plus k. So to review, there are some things to review real quickly. Talk about your rules for exponents. And the rules for exponents that we need to look at is what happens when you multiply like bases. We've done that. You're going to add your exponents. When you are raising a power to a power, that's when you multiply. These two we've really talked about. It's the division that we really haven't talked much about so far this semester. So when you're dividing like bases, you're going to subtract your exponents, and that's not a problem when the numerator has a larger exponent value than the denominator. Or when you have x to the fifth divided by x to the fifth, anytime you have anything divided by itself, you're going to get 1. So the next is, let's look some more at this division, and if I have x really to the third power divided by x to the fifth power, these are just kind of all listed out, and we cross off those factors that are the same between the numerator and the denominator. You get 1 divided by x squared. So if I were to write this with the exponents, x cubed divided by x to the fifth, and you subtract your exponents, you end up with this negative exponent. So that just tells you that this base, whatever's in front of the negative exponent, it's in the wrong part of the fraction. And since this really is x over 2, it means that I need to put that x, that's x to the negative 2 power over 1. So that tells me that this x needs to be in the denominator of the fraction. So it really should be written as 1 over x squared, which matches what we've got here. So how's that going to work with what we're doing today? Well, we're going to get to that in a few minutes. But a function and its inverse function can be described as the do and the undo functions. So a function takes a starting value, performs some operation on this value, and creates an output answer. So the inverse function takes the output value, performs some operation on this value, and then arrives back at the original function's starting value. So let's see what this means. So a function and its inverse function, I'm going to first describe these in words. So I'm going to let all of this print out, and then we'll take a look at what this says. So this says here that this function multiplies the input by 2 and then adds 3. So you can see it's going to multiply by 2 and add 3. So if the inverse undoes that function, it will take the output and it will subtract 3 and then divide by 2. So you're working backwards. Adding 3, subtract 3. Multiply by 2, then divide by 2. So let's look at the tables for this. The tables are really helpful. So notice that in the tables, here is your starting value, your negative 2. We're going to perform some operation, essentially, and for this one, we're going to multiply by 2, and then add 3, and get this output value. So for the inverse, we're going to take the output value and somehow arrive back here at what was the input value. So we said that by doing the opposite, so by taking this output value, subtract 3, divide by 2, every time that will take us back to the original input for the original function. So what about the graphs? So you're looking at the graph. Here are these two functions on one graph. So you've got 2x plus 3 and x minus 3 quantity divided by 2. something sort of interesting when you look at the graph is that once you graph this line, y equals x, notice that really the inverse function is the reflection of the function over this line y equals x. Notice that these are the same distance from that line y equals x, so it's a reflection. So one thing you need to be careful about is some of this vocabulary, the semantics. Inverse of a function versus inverse function. Inverse of a function is the relation formed when we switch out the x and the y in a relation, whereas the inverse of a function itself, if that is a function, then we can call it an inverse function. So because not every function has an inverse that's also a function. So you have to be careful with that. So how do you find the inverse of a function without having to go through all that work? So basically the process of finding an inverse is simply to swap the x and the y coordinates, excuse me guys, and solve for y. So the newly formed inverse will be a relation, but may not necessarily be a function. So now that's the second time it's been mentioned, so that's pretty important to keep track of. So what are exponential functions and how does this work with what we're talking about today? So if you look at the parent function for an exponential function, we can look at this. And we could talk about where a is not equal to 0 and represents the starting or the initial value, and b is not equal to 1 and represents the growth or decay value. So for example, we can use that same one that I started out with before, 3 to the x power. So let's take a look at what's next here. So exponential growth versus decay, how do you know when you have which one? So if your b is greater than 1, you've got exponential growth. If your b is between 0 and 1, you have exponential decay. So exponential growth, your graph will look like this, and your domain are all real numbers, and your range will be, notice that there is a horizontal asymptote here. Y is always going to, your range is greater than 0, never equal to. It's going to approach that curve approaches the horizontal asymptote. And again, your domain are all real numbers, and your range is greater, y is greater than 0. So I'm going to stop the video here, and what I want you to do is, you've got some examples that I want you to sort out on whatever is the next page in your notebook. Make a column for exponential growth, exponential decay, and then just glue those little cards in the right column on that next page.